Note before I continue on this video. At the end of the last one, I wrote the code, but I never actually saved and tested it. So I'm going to do that now. I'm going to run this for loop. And again, I'm not really expecting anything to happen, but I'm not expecting a mistake. But what I do want to point out here is that when I was doing the while loop, it didn't give me these 3 chevrons and end the program. When I do the for loop, it does give me these 3 chevrons and ends the program because it's done the entire list. It's gone along the entire list. This one is waiting for something to be found and so won't report back. So let me just show you that quickly. Let me run both programs again. Let's start with the while loop and notice that it's conditional. It's waiting for something to happen. Okay, we haven't found anything yet, so we can't report anything back. Whereas in the for loop, it will run the program, and because it's looking at every single data item and reaching the end of the list, it does report back and ends the program, even though it never found anything. So there's the difference between a while loop and a for loop, and a hint in the shell as to what may be going on. Right, let's take a look at the while loop. Let's see if we can go through it. We need to compare our item with the value at the index in data. Now, I know I've got 6 elements in this list, but I can really extend this list as much as I like, and I'll show that at the end, and I won't need to change my coding. So let's do that. Let's compare. So to compare, we need to use an if statement. So if what? If D, which is my data, remember I chose D just to shorten my programming and to prove a point that you can have arguments and parameters which are different. But they must be, I can't swap them around. I can't have data and item here and then have I and D there. That would be the wrong way round. I would then be the data. So data at index, remember we are indexing into an array. So there's my array data, and I need my square brackets to look at a particular place inside it, and the value there is index, which at the moment is 0. So I'm looking at the very first element in my list, and I'm checking to see if that is equal to, now don't forget comparisons with if statements are double equal signs. What I'm looking for is if that is the same as my item, and item was passed in as the value I, so I'm checking to see if D, data, at 0 index is 3. And so that's the start of my if statement. And if it is, if it's the same number, then I can say that I have found it. And all I need to write is found equals true. Now that's setting the opposite value inside the loop. That will ensure that the loop will stop there. This is an and, so we're going back to logic. Both of these need to be true for the loop to be entered. So thinking of binary, this needs to be a 1 and this needs to be a 1 for us to enter the loop. So if found is false, well, false is 0, not false is 1, and index is not equal to the length of D. Well, index is 0, length of D is 6, 0 is not equal to 6, so that becomes true, so that becomes a 1, so it's 1 and 1, it goes inside here. However, if I change this one to true, when I look at not found, well, not true is false, this becomes 0, and this stays at 1, because it's and, it will not go inside and it will break out of the loop and be where my cursor is flashing now. So that's how I'm breaking the loop. I'm setting this value to a 1. The other one is if I run past the end of the list, this one will become a 1 and that will break the loop. Hopefully you understood that. Maybe you didn't. Maybe we need to go over that a little bit more at a later date because of the logic. So if we found it and we set found to true, but if we haven't found it, what we need to do is look at the next number. So I need to make index go up by 1. So I need an else clause. So if it's not the value I'm looking for, I need to make the index value go up by 1. So index equals index plus 1. And that is my loop for the while version. So I'm going to save that. I'm going to run it. The problem is we're not displaying any values or anything else. But if I run this program this time, what we're going to see is that the program ends. Remember last time it didn't, it was waiting. So it's ended. It must know that either it's found it or I've reached the end of the list. So let me type index. Did I reach the end of the list? If I did, then index is going to be 6. Oops, I can't use it in here at the end of the program. We'll have a look at that later. If I type found, yeah, I've got the same thing. The program has finished, so I can't look at these variables. We'll look at that later. Let's do the for loop. The for loop is not so big. We still need exactly the same comparison. So I'm just going to pinch it. So I'm going to pinch that comparison to show you that we just need exactly the same comparison. So if, excuse me, if we find our item at that particular index, in other words, if we have found it, then what we need to do is stop looking along the list, because for is going to look at every item in the list. We need to say, whoa, get out of there. And we we type the command break, and that stops when it's found it. So it's either going to find it and break out of the loop, or it's going to run all the way along the loop and not find it. But we're not going to produce an error because we're only going to look for the length of the list. Now this, the keyword break, is quite common in some other languages, such as BASIC. I personally think this is a really bad idea as a programmer. I don't like the use of breaks, and I don't like another keyword called continue. They are what we call hacks. In other words, it looks nice, it's a shorter amount of code, but really this is the best way to write the program. We can test each variable as we go through. Breaks just appear in programs. We don't know what's going to happen or why things are breaking. It's a hack. We forced it to crash, and we don't really want to do that. But it does look neater. I mean, it's only a few lines of code, does the same job, and we can prove that. So if I save and run this, it will do exactly the same job. There you go. It's broken out and ended the program without an error. Fewer lines, however, that keyword there is something that I don't want to see. However, you may see it used in the exam, which is why I have done this kind of loop. To be truthful, this kind of loop should never be used for this kind of problem. This really is a conditional loop, and we should really always use this one, the while. So, okay, both programs seem to work, but what we're not doing is reporting back what we have found. And this is where, again, the for loop is going to be a little bit different to the while loop in what we need to figure out and test. So in the next video, we'll look at reporting back what we found.